Hello, this video will show you the new linear feature extraction command in TPC version 540. The new linear feature extraction command creates line strings from overhead utility lines and curb and gutter features displayed in a point cloud. First, I will demonstrate overhead line extraction and then move on to curb and gutter extraction. With an MX9 scan dataset displayed in the 3D view of my project, I can navigate to the Point Clouds ribbon and select Extract Line Feature under Deliverables to display the Extract Line Feature command pane. First, I will ensure my extraction type is set to overhead lines. We next have an option to enter a name, assign a layer, line style, and color to the extracted line strings by expanding the Line Settings heading. Here, I will enter Demo as my name and select Powerlines as my desired layer. Now, in the Extraction Group box, click in the Start Point field and then come to the 3D view to select the starting point for the overhead lines you want to extract by clicking on the pole. A green icon indicates the line's start point. Your cursor will automatically move to the endpoint fields where we can then select the ending point in the 3D view. A pink icon indicates the line's endpoint. Next, the cursor automatically jumps to the Lines field, so I can click directly on an overhead line that I want to extract. If you do not click on a scan point, a red icon will display. The extraction occurs first in one direction from your selection point to the start point, and then in the other direction to the end point. When you click on a wire, a green box appears indicating the specified search length and search width in my 3D view. A line string will be extracted in multiple segments for each selected overhead line. Each segment is based on the specified search length. We can adjust the search length and search width by utilizing the slider control or manually entering in a desired value. Here I'm going to adjust my search length to 2.5 meters and my width to 0.6 meters. We can see the green search box automatically updates in the graphic view to reflect my new inputs. For fastest processing, you might define a search box that is as long as possible so there are less extraction segments to create. You also might want to make the search width as narrow as possible so there are less extraneous points to consider. However, you must consider how to best handle situations of sparse scan points and drooping overhead lines. If the search box is too short or too narrow, each extraction segment may not include all of the points required for the line string extraction, causing the extraction to stop. After my search length and width are appropriately adjusted, I can put my cursor back in the lines box to select more power lines for extraction. Now that I have all of my selected overhead lines, I can go ahead and click Extract or press the Enter key. A progress bar displays at the bottom of the window. Each extracted line segment is displayed in magenta as the extraction runs, and successfully extracted overhead lines will appear in magenta when the extraction is done running. If at any time we want to delete our work or start from scratch, we can simply hit the discard button at the bottom of the commands pane. Now, I'm going to briefly observe a different point cloud dataset to see what happens when the extraction encounters a problem, such as sparse scan points. If the extraction stops before completing, the extraction line will turn from magenta to red. We can zoom into the 3D view to see where the extraction encountered a problem. In this high-tension power line dataset, we see the scan points become sparse and one line did not finish extracting. At any time, we can hit Undo to delete previously extracted segments, or click Switch Direction to start extracting in the opposite direction. The Switch Direction button is disabled here since the extraction successfully made it to the start point in the opposite direction. To aid the extraction where it stopped, we can adjust the search length or width to capture applicable scan points, then hit Extract again. or we can utilize the additional options as a mid-QA QC tool. You can select the Continue Straight option and click Extract to specify that the extraction line will continue on its current trajectory path until it's able to identify additional line scan points or until it reaches the start or end point. Moreover, if I click the Select Next Point option, I can select the next scan point in the 3D view to use for the continuation of the extracted line, then click Extract. As with the Continue Straight option, this tool is useful when there is a section of the overhead line that is obscured or has little to no scan points. However, Select Next Point may be a better choice if the Continue Straight option creates segments that do not align with the actual overhead line. We can click the Finish button to complete the extracted line if the line does not automatically finish at the start or end point. Coming back to my original TBC project, I can either hit Add in the Commands pane to add the extracted line strings to my TBC project, or I can navigate over to the Post QA/QC tab to make a few more modifications. Here, I'm going to open the Post QA/QC tab. The Post QA/QC tab allows us to do any of the following. We can activate the limit box to give us a clearer view of a single extracted overhead wire. We can use the forward and backward buttons to highlight each of the extracted line strings for review. Then for the selected line string, we could hit Ignore, in which the selected line string turns red and will not be saved, or we can mark it for reference by creating a white line string. Under the Smooth Line options, we can select Original to leave the line string as is, or we can hit Best Fit Line or Smooth Curve to enhance a selected line string. Hitting Apply to All will apply the smoothing options to all of your extracted line strings. You can experiment with the two options to determine which option best fits your needs. In this case, I'm going to apply a Best Fit Line to all of my extracted line strings. Lastly, the line settings can be adjusted for a selected line string. Here, I will not make any further modifications. Once our overhead lines are validated in the Post QA/QC tab, I will hit Add All to save the line strings in my TBC project. If we want to extract more power lines from the current dataset, the Commands pane automatically switches back to the Extract tab, where we can repeat the linear extraction workflow. Overhead line extraction is even capable of extracting power lines that extend down to the ground, or power lines that run across a street, as I will demonstrate now. The start and ending points for your extraction do not have to fall on a power pole. Next, I will demonstrate the curb and gutter linear extraction workflow with an MX9 scan dataset. In my TBC project, I will navigate to the Point Clouds ribbon to open the Extract Line Feature Commands pane again. This time, I will ensure my extraction type is set to curb and gutter in the drop-down list. The curb and gutter extraction process will result in the creation of 4 line strings. Each line string will be based on nodes that define a cross-section profile view. First, I will expand my line settings to enter in Demo 2 for my name and set my layer to curb and gutter. I am then going to rotate my point cloud in the 3D view to obtain a top-down view. In the Define Cutting Plane Group box, click in the Point 1 field, and then in the 3D view, select a point on the sidewalk. Here, I'm going to make my selection on the back of the curb. My cursor automatically jumps to the Point 2 field, where I will make my second selection at the edge of pavement. Be sure to make the second point selection directly across from the first point so that the magenta connecting line is perpendicular to the curb and gutter. This ensures that our curb and gutter profile is clearly defined in the cutting plane view. Points 1 and 2 do not have to be selected on the edge of pavement and back of curb. However, putting these points on these locations will help me identify the edge of pavement and back of curb in my cutting plane view. After my two input point selections are made, a cutting plane view automatically opens up under the 3D view, displaying a vertical cross-section of my curb and gutter. The sides of the curb and gutter you choose for point 1 and point 2 determine the direction in which the extraction will start. The direction of extraction is denoted with a white arrow in the 3D view. If you want to change the direction at any time, we can hit the Switch Direction button. Next, I will define the curb pattern profile to be used as a template by the extraction process. Click in the Node 1 field in the curb pattern group box, then in the cutting plane view, click on the scan points where it appears to be the edge of pavement or where you want your first node to be located. Since I made a selection on the edge of pavement when defining my cutting plane, I can be reassured that the blue dot in the cutting plane view is where the edge of pavement is located. The cursor automatically moves to the Node 2 field. Click in the cutting plane view again to select each of the other three node locations. In my project, Node 1 corresponds to the edge of pavement, Node 2 to the flow line, Node 3 to the top of curb, and Node 4 to the back of curb. Again, I selected a scan point on the back of curb when defining my cutting plane, so the green dot in the cutting plane view is where my back of curb is located. Now, in the extraction group box, we can enter in an extraction interval as well as a minimum confidence value. The interval specifies the length of each segment to be searched and extracted at a time. For faster processing, you may define an interval that is as long as possible. This can work well with long stretches of curb and gutter with minimal profile change. However, you must consider how to best handle situations of changing feature profiles, curving features, and sparse point cloud data to minimize how often the extraction will stop. Here, I will enter in an interval of 3 meters. The minimum confidence field specifies the minimum confidence with which you want the software to identify points correctly. The higher the value, the more precise the extraction is, but the higher the likelihood of the auto extraction stopping. On the other hand, the lower the value, the less precise the extraction is, but the lower the likelihood of the extraction stopping often. I will set my minimum confidence value to 85%. Anytime the extraction process encounters an issue that causes the confidence level to fall below our input value, such as sparse scan points or a change in the curb and gutter profile, the extraction stops and options are enabled for you to continue. We can adjust the interval and minimum confidence value anytime the extraction stops. Before hitting extract, I'm going to rotate my 3D view so I can get a better view of the extraction running. We can also press the Enter key to start the extraction process. In the graphic view, each extracted line string is displayed in green, and a status bar displays at the bottom of the TBC window, showing the progress for each extracted interval. When the extraction reaches the edge of my point cloud dataset, I can hit Switch Direction, then Extract again to run the extraction in the opposite direction. When the automatic extraction stops in the 3D view, we can use the additional options to continue. The Edit Template Nodes radio button allows you to manually select each node and move the node to its correct position on the feature profile in the cutting plane view. Here, I will also decrease my interval to 1 meter around this corner for better accuracy. If we zoom in close onto our point cloud where the last extraction interval stopped, we can see small purple tick marks that correspond to the 4 nodes we define in the cutting plane view. These tick marks are always present and can serve as a visual aid to make sure our curb template is accurate. We can hit Extract to continue after our nodes are adjusted. We can watch the template confidence drop in the commands pane as the extraction encounters a change in elevation, so I will adjust the template nodes again. Zooming in, we can see that adjusting the nodes causes the extracted line strings to better fit the curve pattern profile. Next, I will observe an X7 scan dataset to explore the other additional extraction options. It is important to remember that the performance of the linear feature extraction tool is dependent on how good our scan data is. If there are gaps in the data or obstructions such as cars, this can have a negative impact on the extraction results. Here, we see a curb and gutter profile with elevation changes. When I hit extract, the extraction stops due to a change in the slope. We can see that the template needs to be updated. Luckily, the Apply Auto Template tool automatically realigns the nodes and snaps them to the point cloud. We can validate the Apply Auto Template tool by hitting Apply prior to resuming the extraction. Now, the Select Next Node Point option is useful if scan points become sparse or if the extraction encounters a turn or change in elevation. We can choose what node will be used as a reference to place this manual step. Then, in the 3D view, I can click on a point to place the next interval step. Zooming in, we can see that my selection of node 2 as a reference nicely aligns the manual step to my previously extracted interval. Hitting extract will extract the next segment, and clicking extract a second time resumes the auto extraction. I will use the Apply Auto Template tool again to realign my template nodes, then place a couple more manual steps with node 2 as my reference node. I will use the Edit Template Nodes tool to adjust the template again. I can hit Extract to resume the auto extraction. At any time, we can click Stop to pause the extraction and Undo to remove segments. I will adjust the nodes once more for better accuracy. Lastly, the Select Search Points option is useful if we encounter a problem area, such as sparse scan points or a sharp turn around a corner. Unlike selecting the next node point, we can place multiple search points in the 3D view for the extraction to follow. The search points should be placed in the middle of the template. Here, I will use the Select Search Points option to turn a corner. Coming back to our original TBC project, I will use the Select Next Node Point option in conjunction with the Apply Auto template to complete my extraction. We can hit the Finish button when our extraction is complete. The cutting plane view closes, and the green line segments turn into magenta line strings. Now we can either hit Add to add the extracted line strings to our project, or navigate to the Post QA/QC tab as we did with overhead lines. The Post QA/QC tab is identical to the overhead lines workflow. Here, I'm not going to apply any smoothing options to my line work and leave the line settings as is. I will hit Add All to add my completed curb and gutter line work to my TBC project. Thank you for watching.